There are a couple of questions that have appeared on your A-level board exams that require that you use the remainder and factor theorems. So the first question says P of x is equal to x cubed plus ax squared plus bx plus 8. When P of x is divided by x minus 3, the remainder is 2. And when divided by x plus 1, the remainder is minus 2. Find A and B. Okay, so they have given us the remainder after two divisions. The first one, P of x is divided by x minus 3, the remainder is 2. And the second is P of x when divided by x plus 1 gives a remainder of minus 2. So if I were to write this out using the remainder theorem, what it means is, in the first case, I take x minus 3 equal to 0, which implies that x is equal to 3. So if I input 3 into the p function, I should get a remainder of 2. So p of 3 is 2. Similarly, x plus 1 equal to 0 gives me x is equal to minus 1. If I input minus 1 into the p function, I get the remainder minus 2. So I'm going to write out these two equations, and I'll probably end up with simultaneous equations which I can then put into the calculator and figure out the value of A and B. Okay, so the first one, P of 3, is going to be 3 cubed plus A into 3 squared plus B into 3 plus 8. So that's 27 plus 9A plus 3B plus 8, and remember P of 3 is 2 from here. So this is my first equation. 9A plus 3B is equal to 2 minus 8 minus 27. I'm going to put that into my calculator. So 2 minus 8 minus 27. That is minus 33. So that's my first equation. 9A plus 3B is equal to minus 33. Right, now I'm going to set out with my new equation. P of minus 1. So P of minus 1 is minus 1 cubed plus A times minus 1 squared plus B times minus 1 plus 8. So that's minus 1 plus A minus B plus 8 is equal to minus 2, which gives me A minus B is equal to minus 2 minus 8 plus 1. So that's minus 10 plus 1, which is minus 9. That's the second equation. Now I'm going to just put the two equations into my calculator under the simultaneous equations function option, and I get A is equal to minus 5 and B is equal to 4. The next question involves both the factor and the remainder theorems. So we are given p of x is equal to 2x cubed plus 7x squared plus ax plus b. Given x plus 1 is a factor. So when they say x plus 1 is a factor, it means that the remainder is 0. And then when p of x is divided by x plus 2, the remainder is 5. Find a and b. So here, the first statement, given x plus 1 is a factor, we find the value of x first by equating x plus 1 to 0. So this gives me x is equal to minus 1. P of minus 1 must be equal to 0 because x plus 1 is a factor and the remainder of, must be 0. The next one is when p of x is divided by x plus 2. So I'm going to equate x plus 2 to 0. I get the value of x equal to minus 2. So p of minus 2 gives me a remainder of 5. So p of minus 2 must be 5. These are the two equations that I'm going to make and solve simultaneously. Right, so p of minus 1, using the function given to us, 2 minus 1 cubed plus 7 minus 1 squared plus a into minus 1 plus b. That gives me minus 2 plus 7 minus a plus b is equal to 0 because x plus 1 was a factor. So minus a plus b is equal to minus 7 plus 2, which is minus 5. So minus a plus b is equal to minus 5. That's the first of our equations. Moving on to the equation that has a remainder. 2 into minus 2 cubed plus 7 into minus 2 squared plus a minus 2 plus b is equal to 5. So here we get minus 16 plus 28 minus 2a plus b is equal to 5. So minus 2a plus b is 5 plus 16 minus 28. Now 5 plus 16 minus 28 gives me minus 7. So minus 2a plus b gives me my second of the simultaneous equations. Solving equations 1 and 2 by putting the values into the simultaneous equation function of our calculators, we end up with a equal to 2 and b equal to minus 3.